This video will cover the strategies needed to solve the following types of isotope problems. 1. Determine the symbol of a specific isotope if given its name. 2. Determine the name of a specific isotope if given its symbol. 3. Evaluate the numbers of protons, neutrons, and electrons in a neutral isotope. And 4. Evaluate the numbers of protons, neutrons, and electrons in an ion. To go from name to symbol notation, let's start by interpreting the two pieces of information provided in the name. The number 57 refers to the mass, A, of this specific isotope. The element, iron, has the symbol Fe. Recall that the symbol notation for an isotope is set up like this: AZX, where the mass number A is at the top and the atomic number Z is at the bottom. The atomic number is never explicitly part of the name, but we can always find it on the periodic table. Viewing the element block for iron, we see that the atomic number Z equals 26. To write the isotope notation, we first write the symbol Fe, then we write the mass number from the name, 57, at the top left, and the atomic number we looked up, 26, at the bottom. Continuing with this problem, we can now evaluate the numbers of protons, neutrons, and electrons in the iron 57 isotope. The number of protons equals the atomic number Z, so protons equals 26. Because protons plus neutrons equals mass number, or red plus blue equals purple, we can rearrange this to solve for neutrons as A minus Z equals N. Here's a useful trick. Always set up this neutron math directly on the isotope symbol. 57 minus 26 equals 31. So neutrons equals 31. If the number of neutrons turns out to be negative, which isn't possible according to the laws of physics, then it probably means you have the A and Z reversed. Because this is a neutral atom, the number of electrons must balance the number of protons. So the number of electrons is also equal to Z, or 26. Let's analyze the information we're given in the symbol to determine which parts make it into the name. The top number, 84, is the mass, A, and is the number that is used in the name. The bottom number, 36, is the atomic number Z, and is not used in the name. The symbol, Kr, is for the element krypton. When we write the name, it takes the format element name hyphen mass. So the name of this isotope is krypton 84. To figure out the protons, neutrons, and electrons, we'll first look up the atomic number for Be, which is beryllium, and we find that Z equals 4. We write this value of Z at the bottom of the notation. The number of protons equals the atomic number Z, which is 4. Remember that the top number 10 is the mass number, and for neutrons, we'll do the subtraction of A minus Z within the isotope symbol. 10 minus 4 equals 6. so the number of neutrons equals 6. And finally, the number of electrons for a neutral atom is equal to the number of protons, so electrons equals Z equals 4. Here, our isotope is an ion, which we can recognize from the charge shown as a superscript on the right. Determining the protons and neutrons follows the same process for an ion as it does for a neutral atom. It's only the number of electrons that will change, and we'll talk about those details in a little bit. The mass number A equals 80. The atomic number is 34. So the protons equals 34. And the neutrons are calculated as 80 minus 34 equals 46. For the electrons, be sure to follow the steps in order. First, start with the number of electrons in the neutral isotope, which is Z equals 34. Then, let's look at the two parts of the charge of the ion. The value, which is 2 in this case, is how many electrons are involved in forming the ion. The sign tells us what to do. Because this is a negative ion, we will add 2 electrons to Z to get the total. Electrons equals 34 plus 2 equals 36. The mass number equals 65. The atomic number Z from the periodic table is 29. So the number of protons equals 29. Calculate the neutrons as 65 minus 29 equals 36. For the electrons, start with Z equals 29, the electrons in the neutral atom. Then look at the value and the sign of the charge. The value is 1 and the sign is positive, which means 1 electron will be removed. So 29 minus 1 equals 28.